So in this video, we will use series sum and polynomial regression for power law decay model of a Maclaurin series expansion. Here we have an equation where y equals a times a power law equation with y equals a times b to the power x, where the values of a is 3 and value of b is 0.3 because it's a power law decay model. The equivalent in the exponential form will be a times exponent cx, where the value of c is ln b, which is negative 1.2. We will generate the power law model, which is a times 1 plus x ln b, which is also c, plus x ln b to the power 2 over 2 factorial, plus x ln b to the power 3 over 3 factorial until x ln b to the power n over n factorial. So we have our values of the power which start from 0, incremented by 1, and we will assign up to n, or n equal to 10, and we enter the coefficient part of the factorial part of the coefficient, our formula, 1 over factorial of the values of n. Then we can complete the series sum, which is Ra formula of A, which is 3, times series sum of x times ln b, which is negative 1.2. And the power will start from 0, incremented by 1, and the coefficients will be this range. Now we will graph this data set using scatter chart, and we'll show the trend line equation, which is polynomial. Our trend line equation now is y equals 3 times exponent negative 1.2. Our 3 is Ra, and c, which happens to be ln b, is negative 1.2. We will calculate this. We'll show this we'll regress this data set using Linus, the polynomial Linus form. First, we generate the 1 comma x matrix, because the estimated y equals this matrix times the coefficient. This matrix is the 1 comma x matrix, and this is the coefficient which can be generated using Linus. So we start with the 1 comma x, which is Ra formula of these values raised to the power 0. And the x column will be Ra formula of the x values raised to the power 1. And the x squared column will be Ra formula of the x values square. And third one, the x cubed column will be Ra formula of the x values cube. Now that we have 1 comma x matrix and our y values, we can enter the Linus in the polynomial form, which is Linus data y and data x, which starts from here, where we have the x values. And we enter the full statistics. And here we have the 12 outputs. Our B0 is negative 2.96. Our B1 is negative 3.51. And our B2 is 2.44. And our B3 is negative 0.995. We can show this in the chart. All we have to do is change the chart, change our trend line into the polynomial, and to the third degree. And here's what we have. To the third degree, our B0, 2.96, rounded up as 2.97. Our B1, negative 3.59, is negative 3.59. Our B2, 2.449, rounded up as 2.45. And our B3, negative 0.955, is rounded up as 0.956. We can now enter the estimated y. This is equal to m multi of our 1 comma x matrix and the coefficients b. And we will enter this in the chart. So we added the chart, add this range to the chart. And we'll show the equation also as well. This time we'll go back to the trend line using the exponential. And we'll show the r squared as well. Okay. Our r squared is 1, meaning it's perfect. And our exponential form will be also the same. Our estimated y, even if we use the polynomial or the polynomial regression, we still get the same exponential coefficients, 3 times e to the negative 1.2x, where the value of this 1.2 is the value of c.